let's do another problem, shall we? Today I feel better about it. I know that it's easier than the last 2 times. At least that's medium, not a hard one. Okay, so I've shared my screen. I haven't chosen the right layout. Give me a second. This is the right layout. Nice. And now let me remove that and start the timer, for which I now have a special separate program. Okay. Train traveling 1 year in advance. The days of the year in which you will travel are given as integer rate days. Each day is an integer from 1 to 365. There is a 1-day pass that is sold for costs $0. Then 7-day pass that is sold for costs 1. Okay. Okay, so as far as I understand, is it just 2 arrays, or so it seems that we are getting an array days, which is a list of integers, and then it looks like to travel every day in the given list of days. So it seems like we might not want to travel on some of the days and might want to travel on other days. Okay, but then is costs just an array of 3 numbers, or it depends on each day? Like if you buy a ticket on day 303, then it will be one set of costs, and if you buy a ticket on day 12, it will be a different set of costs. So let's see, days and costs. Okay, costs are always the same. I see. So costs will be list of integers, and then we need to return an integer which has the minimum number of dollars that we can use. Okay. Let's say that we have like 1, 2, 3, 7 as days that we need to travel, and let's say that costs are 5, 30 days, right? 30, 5, 10, 20. So we don't have 3-day passes, we have just 1-day pass. So on each of those days, we can choose whether we want to buy one of those tickets. Okay, so for example, on day 1, we can buy 1-day pass. Then on day 2, so for each of those, we can buy 1-day pass. And then I'm thinking already about the solution, which seems like a dynamic programming solution. So I'm a bit distracted here, but yeah, let's say we buy 1-day ticket on each of those days, then it will be 5 times 5, so 25. But we can also buy a 7-day pass on the first day, which will be for these first 7 days, it will be $10. And then for 30th day, we can buy another ticket that will be 1 day pass, and it will be 5. So it will be 15 in total. And then there is also an option to buy 30-day travel pass for all of those days, and it will be 30. Okay, so um, okay, so here the correct answer is 15, and I'm thinking about the solution. And the solution, I'm thinking about a two-dimensional matrix where we have costs as a vertical, right? So it basically costs will be 1, 7, or 30-day costs. And then here we will have days, and it will be like so it will be just our list of days. So for example, here it will be 2, 1, 2, 3, 7, 30. Then the value will be what is the minimum price. Okay, let me also, I'm assuming right now that the days are ordered, so let's just also say that they don't have to be ordered. So it will be the same thing here, but just to highlight that they don't have to be ordered, so we will have to order them first so that we can put them like this. And here in the cell elements, it will be, if we use this cost on this day, what is the minimum amount of money that we have to pay? So what does it mean? Here we will have, like, if we pay cost of 1, so we just pay for 1 day, so we need to move 1 cell to the left and find what was the minimum time there out of 3 options. Then if we pay cost for 7 days, then we need to go 7 days ago, but we don't know which cell will it be, so we will need to use binary search to find which of those cells we are landing at. Obviously we can do linear search, but then it will take us more time. Also we can just do a line of 365 days, and then we will be able to easily jump to the correct place. But it can be that our number of days that we are considering is several orders of magnitude smaller. So it basically depends. If we have so here for each of those days, we'll need to do log of n operations if we are using binary search to find the specific previous date. And we will need to do it for each of those values of cost separately. So it will be like, let's call it of d times c values, but let's call it like, let's say there are n days and m costs. So of nm, and then log of n for each cell. Okay, so for each of those cells, we do log n operations to find the correct previous cell, and then we find in of1 the correct value. So this is the best possible time that we can get. But if the number of days that we are considering is the same order of magnitude that this number of days. It can be O of nm if we just consider all the possible days here, and we need to figure out like each time which is faster, because okay, here n is like 365. So if n log n is smaller than 365, then we should go with this solution. Otherwise, we should go with this solution. And it will be of nm space runtime if using the defined set of days, if using 365 days. And in this case, then we will just need to find the last day. But yeah, I think it won't work actually correctly, because we will be considering like all the days as if we need to travel on those days. We can do some tweaks by like selecting costs only for days where we actually need to travel. But yeah, I think this solution then becomes overall better one. So let's just probably needs work. So let's focus on the solution with binary search. Okay. Implementation. And we are assuming that it's just like 100 or 365 days for 1 year. So we start with like zeros for all costs at the first day that we are considering. Okay, so let me copy this. And I'll be writing now the dynamic programming solution. So n is length of days, m is length of costs, dp is 0. Okay, should I add another day to the left, like 0th day? Let's do this maybe. So times n plus 1. So there will be another 0th day that we will mark with zeros as costs. So 0 times n plus 1. And yeah, now it will also be indexed with 0, so it will be easier to track days. Okay, for in range so now we have the correct number of rows and correct number of columns. And let's see, so for day in range from 1 to n plus 1. Okay, no, for day in days. For cost, for it's not like cost and costs, it's okay, it's always 1, 7 and 30 days. So let's say that I'm trying to pack this so that it's nice to work with. Let's say we have tickets, and it will be zip of 1, 7, and 30, and costs for period cost in tickets. So now we need to find the previous day that is still the last day before the current one, right? That is, yeah. So we are first subtracting the period from the current day. And then we need to do bisect. Let me see. So for example, for these days, we will also have 0 day added, right? So for this, it's not cost, it's like period, right? So for period, we are doing 1 minus 1, which is 0. So then we need to find exactly this 0 in the index. That's fine. But what if we, for example, do 7? 7 minus 1. We need to find 3. So we need to find either the element or the element to the left of it. So if it will be bisect left. So index bisect left. So what are we bisecting? We are bisecting days, right? No, we are bisecting. So yes, let's do. I'm trying to think about how to create this elegantly, but let's just say bisect days is 0 plus days. So we need to bisect days in search for day minus period. And then we need to find the smallest value in this column. So min pref cost is equal to dynamic programming. We are choosing the index, 0 index. The solution will be brittle in case there are more costs, but for now we just consider those 3, and we already have some hard-coded values. So once, if there are more, we need to reconsider some of the solutions, some of the approaches here, but for now, I think this is fine. Okay, so no, not plus, obviously. We need to choose the minimum value out of those 3. So this is the minimum previous value. And now we need to set it dp of the current. Oh, I also need an index, right? Okay, so let's then do let's do days will be updated like this, and here we will be only using days 1, and here we also need to do day minus period max of day minus period and 0, because we cannot go back more than to the 0th day. And here we will also need for index if enumerate. Okay, my timer has ended, so let's stop. Let's do 10 minutes more. Okay, dynamic programming. Which value should I choose now? So we are enumerating dynamic programming of this cost. Okay, this also J costs and enumerate tickets. So we need to enumerate everything here. So dp of row J and day, which is I plus 1. Yes, will be the current cost plus median previous cost. Okay, now what we will be returning? We will be returning -1, -1, -1. Minimum of these 3 values. Okay, this looks correct. Now let's actually quickly populate this matrix. As part of the solution. To check ourselves. Okay, so here it will be 0, 0, 0. Sounds good so far. So this is our DP, and it will be zeros from the beginning. So our days will be looking like this. That's correct. And DP will be looking like this. That's correct. What we're showing here, right? So now for I and day and enumerate days. So starting at this day, we are enumerating this. So the index of this I will be 0, 1, 2, 3, 4. Okay. And then for J, period and cost. So J will be 0, 1, and 2. I guess that's fine. And now we need to do index, bisect left. So we are bisecting days. We are bisecting this array. We are looking for day minus period. So day will be 1, period will be 1. And we are subtracting those, so we are looking for 0 in this array, and we are looking for index of this array. So we have found 0 in this array, that's fine. And we are selecting like minimum previous cost out of these 3. So here it will be Is this actually correct? it's like if we have bought, yeah, I think this is correct. I was worried about like when are we buying this particular period ticket. So here, if we are buying ticket for the period of 7 days, it's as if we are moving backwards in time, but I think it's fine. Okay, again, so here the cost will be 5. Here the cost will be 10. And here the cost will be 20. So now the cost for day 2. Let me see that we are populating things correctly. So dpj, j will be 0, 1, 2, and the index will be 0. So this index is 1. This is correct. Mean previous cost. We have found the index is 0. So we are looking for this, for 0 in this array, and the index will be 0. Okay. Yes, we're looking up numbers based on index, populating numbers based on I. Both things are correct. Now for this day 2, we will be looking at minimum value plus value of this day. So it will be 5 plus 5, 10. And we are buying now 10 plus 5, 15. And we are buying now 20 plus 5, 25. So now for day 3, it will be 15. Oh, actually, no. Actually, here, it's not. Here we will be adding 0, like says. Here it will be 10, because we are adding everything to 0. We are looking everything by bisect. So here will be, for day 2, we will be subtracting period of 7. So 2 minus 7 is minus 5, but we are choosing maximum between this and 0. So we'll be looking at 0, and here it will be 20 again. Okay, looks good. So now this will be 15, but this will still be 10, and this will still be 20. Now here we want to buy, so it will be 15 for day 7, because this will be the smallest value now, right, of the previous day. And here 3 is day 7, 7 minus 7 is 0, so we will be looking at 0, and it will still be 10. And here it will be 20, as it was before. Now finally 30th day. So 30th day we subtract minus 1, and we need to find 29 in this array. So we are not finding 29, but we are finding 7, because we are bisecting left. So we are either finding the number or the number on the left of it. So now we have chosen 7. And for 30, the minimum value for 7 will be 10. So 10 plus 5 is 15. Here we are subtracting 7. 30 minus 7 is 23, so it's still 7. So we add 15 to this 10. Oh, sorry, 10 to this 10, so it becomes 20. And then again, we can pay 20, and it becomes 20. So yeah, the minimum value is 15, and so far it looks good. Let's see. Oh yeah, I have removed bisect days. Okay, There is an issue with my calculation. I'm always returning 0. Okay, I'm returning 0. How can I be returning 0? It only can be possible if there is off by 1 error and I'm not populating the final column or something. Okay, so I'm enumerating day plus 1. Yeah, I know. Okay, I don't want to spend too much time here. Let's first do and GP. We're just never populating anything that is past the first element. Or it's always 0. This is strange. We're calculating this just... Okay, why are we never going farther than the first day? No, we are going farther than the first day. Okay. Okay, so our bisect is breaking once we move past the first day. So there is probably something that I'm not accounting for. Is it that it's always returning -1 if it doesn't find the day? Yeah, I think that might be the case. I might be wrong about how bisect left works. So if it cannot find the exact value, it's just returning -1, not value to the left of what I need to do. So I need to update, either update my search. Yes, I guess I need to update my search. Let's just define a subfunction. Bisect left. Days. Days. Okay. So here we will always need to look for something on the left of our days. So L, we will always be looking for index that is bigger than 0. So L can be 0 and R can be length of days -1. And while L is L plus 1 smaller than L, M would be equal to L plus R minus L divided by 2 if M is, no, days of M is bigger than day, so day at this point is bigger than day, then we need to choose the right, so R equals, no, if day is bigger than day, we need to choose, so the right side is bigger than day. Yes, we need to move the right side, so R equals M, else L equals M, return L. Okay, so now let's change this. Okay. Let's first check that we are never running this again. We are just running it 3 times. What the hell is going on? I really don't understand what's going on here. I feel very stupid right now. But we are seeing the first day, and for the first day we are iterating over J period and cost and enumerate tickets. So we do enter each of these, enter this loop. But for some reason, on other, on the second day, we are still going here. We are still seeing this day, but we are never entering this loop. There we go. Okay. That was a strange bug. I should be using zip more often. Okay, so zip is an iterator. So once you use it once, it won't work for you again. So you, yeah. So once you have iterated once over this list, it's empty. But it's nice to see that our code and binary search works. Okay, so I am moving this. Let's try and submit. Bingo! Finally, we have submitted something that actually works, even after implementing binary search ourselves. And yes, there was a strange bug, but it will still count this as a learning experience and also as a win. Thanks, everyone. See you.